This question falls under the topic of coordinate geometry. In particular, for this question, you need to understand ratio theorem, shoelace theorem, and how the gradients of perpendicular lines are related. Okay, so for part one, right, they're asking for the coordinates of P. Okay, and from the question here, you're given this ratio. AP to AC is 4:5. So this portion is 4 units and AC is 5 units, right? Which means that PC must be 1 unit. Okay, so just a quick recap of ratio theorem, right? If you have a line like that, okay, 3 points lying on the line, and the ratio of the first segment to the second segment is m is to n, right? The first set of coordinates is x1, y1. The n coordinates is x2, y2, right? Then using ratio theorem, right, we can solve for this coordinate that's in the center. Okay, let's call it y. Okay, let's call it point A, right? So this will be xa, ya. Okay, so xa will be equal to x1 times n, right? So you take this multiply by you multiply by the length that's diagonally across, right? So you won't multiply by n, you multiply by n this way. Okay, so x1 times n plus x2 times m. All right, so it's always like you multiply in a cross fashion, x2 times m, and then you divide by m plus n. Okay, then you do the same thing for to get the y coordinate, right? Ya will be equal to y1 times n plus y2 times m divided by m plus n. Okay, so applying that here, right? Our x1 is just -1, right? -1 times n. Our value of n, this part is 1 unit, right? So it's just 1 plus x2, which is 3, times 4 over 1 plus 4. This will be our x coordinate. Okay, and this will just be 1 plus 7, 8 divided by 5. Okay, and then we do the same thing for the y coordinate, right? 2 times 1 plus 4 times 4 divided by 1 plus 4. So this is just, oh wait, I made a mistake, -1 plus 7. This should be -1 plus 12 is 11 over 5. Okay, okay, for yp it will be 2 plus 16, which is 18 over 5. So the coordinates of p is just 11 over 5, 18 over 5. In part 2, we're supposed to solve for the equation of BD. So BD is a straight line. To solve for any equation of a straight line, normally the information that you require is the gradient of the line, as well as any point that exists on the line, the coordinates of any point. Okay, so on BD, right, you can see that actually we just found out from part 1 the coordinates of P, which is 11 over 5, comma 18 over 5, right? And P exists on BD, so that's our point. So now we need gradient, okay, the gradient of line BD. We can see that BD is perpendicular to AC, right? So since we can't find the gradient of BD directly, we can use that relationship to solve for it. Since we can actually calculate the gradient of AC. Okay, so to find the gradient of AC, right, is rise over run. Okay, gradient of AC. The rise is just the difference in the y coordinates, right? How much the line moves up vertically. Okay, maybe I draw it out for illustration. Right, A is -1, 2, and then C is 3, 4. Okay, you want the rise, which is the vertical movement. The length of this, you just look at the y coordinates, right? It's just 4 minus 2. Okay, and then the run is just the horizontal movement, so it's 3 minus -1, which is 4, right? So yeah, that would be the gradient. 4 minus 2 over 3 minus -1, which is 2 over 4, or half. Okay, then for perpendicular lines, right? Okay, AC is perpendicular to BD. How they're related is that the product of their gradients, the gradient of AC multiplied by the gradient of BD, will always be -1. Okay, this is true for all perpendicular lines, right? So since we know that AC is half, okay, then to find the gradient of BD, we divide both sides by half. Okay, so answer is -2. Alright, so yeah, we found the gradient of AC. Sorry, the gradient of BD, and then we have the coordinates of P, which lies on BD. Right, so for straight lines, right, the general equation is always y equals to mx plus c. If you recall, m is the gradient, C is the y-intercept, right? We know the gradient, so we can sub that in. Okay, y equals to negative 2x plus c. So now we are left with one unknown to solve, right? The equation of the line tells us every coordinate that lies along the line, right? So let's say if we know the x coordinate, if then we substitute that in, the equation will give us back the y coordinate, right? So we know that for p, right, the x coordinate is 11/5, right? And since p lies on the line, if we substitute this x coordinate into the equation, then the equation should give us back the value of y. And we know the value of y, so it's 18/5. We can substitute that in, right? So now the only unknown left is c, right? And we can just solve for that. Okay, so 18/5 equals to negative 22/5 plus c. We can add we can add 22/5 on both sides, right? That will be our value of c. So c is just 40/5, which is 8. Okay, and then we substitute back into this equation. Okay, that's our only unknown left. So y equals to negative 2x plus 8. This will be the answer. In part 3, we are asked to find the coordinates of D. Okay, if you observe D, it's a point that lies on three lines, right? AD, BD, and CD. Okay, it's the intersection of all these three lines. If you have the equation of any two lines, right, you can always find the intersection point by doing a simultaneous equation. Okay, this is true for any graphs, right? Like let's say you have a quadratic graph and a line, right? Doing a simultaneous equation will find you the coordinates of the intersection. Okay, so yeah, we have the equation of BD already, right? We have BD. It's a bit hard to find like CD, right? I don't think it's possible to find CD because remember, to find the equation of a line, you need a gradient as well as a single point that lies on the line. We don't have much information to find the gradient of CD, but if you look at AD instead, okay, for AD, it's parallel to BC, right? And we have the coordinate A, which lies on the line, right? So that means it's possible to find the gradient, and we have a coordinate that lies on the line. Okay, why is it possible to find the gradient? You see, we only have one point that exists on this line, so we can't do rise over run to find the gradient. But since it's parallel to BC, right, we can actually find the gradient of BC, and that will be the same gradient for AD. Okay, so let's find the gradient of BD. Let's find the gradient of BC. So it's a rise over run. You see, it's a downward sloping line, right? So the gradient should be negative. We take the difference in the y coordinates, 4 minus 6. I like to do y2 minus y1 because we look at the graphs from left to right. So from the orientation, if it's downward sloping, then the rise will be a negative value. That's why I take the y2 minus y1 instead of y1 minus y2. So then below I also take x2 minus x1, right? You get negative 2 over 2, which is negative 1, right? So the gradient of BC will be parallel to the gradient of, the gradient of BC will be equal to the gradient of AD since they are parallel lines, which means the steepness of the lines are exactly the same. Okay, so the equation of AD will be y equals to negative 1x plus c, right? Okay, we don't write the negative 1 there, we just write negative x. Okay, then now we use the, we know that the coordinates of A is negative 1 and 2, right? So we sub that in, same as what we did in part 2, right? Since x, we have the value of x, the equation should give us the value of y, which is 2. Okay, so we have 2 equals to 1 plus c, minus 1 on both sides, we'll get the value of c. And then we just substitute that back in here. Alright, so we have y equals to negative x plus 1. This is the equation of BC, right? This is the equation of AD. Okay, then remember we're trying to find the intersection point between AD as well as BD. BD we found in the previous equation, we found in the previous part. It's y equals to negative 2x plus 8, right? So since we're trying to find the intersection point, we need to do a simultaneous equation, right? Negative x plus 1 equals to y, and negative 2x plus 8 equals to y. And we know that the values of y must be the same because d exists on both lines, right? So we can just equate the two. Negative x plus 1 equals to negative 2x plus 8. I'm going to add 2x on both sides. So we will have x plus 1 equals to 8, and then minus 1 on both sides. So we have x equals to 7. Alright, so we have the x coordinates of point D. Okay, then to find the y coordinate, right? Since D lies on either line, lies on both lines, we can just substitute x into any of the lines, right? Either the equation of AD or BD. So sub x into 1. We have y equals to, sub x equals to 7 into 1. We have y equals to negative 7 plus 1, which is negative 6. Alright, so the coordinates of D will be 7, negative 6. Okay, lastly, we need to find the area of the trapezium ABCD. So for this, we are going to use the shoelace theorem, right? So how do you use the shoelace theorem? Okay, let's say we have a triangle like that, right? This is A, B, C, D, and E, F, right? We're going to write this formula, right? Half times the absolute value of, and then we can start from any point, okay? So let's start from point 1. Point 1 will be AB, we're going to write it vertically, okay? And then we have to go anti-clockwise. Remember, this one, you're going to be very careful, okay? It only works in an anti-clockwise direction. So if we start from point 1, then the next point will be CD, okay? And then EF, and then back to point 1, okay? Always remember, you must start and end with the same point. So even though it's a triangle, right, we are writing 4 coordinates here, okay? Then, okay, we have to take AD, A times D, plus C times F, plus E times B, and then either you use brackets, right? So let's say we use brackets, then we will subtract B times C plus D times E plus F times A. Okay? If you don't want to use brackets, right, then just make sure you do this. Okay? AD plus CF plus EB, and then you just minus all the product of the other coordinates. So BC minus DE minus AF. Okay? So decide which one you are more comfortable with, and then just stick to that one to avoid any confusion. Okay, so yep. Let's apply this formula here. Okay, I'm going to start from point B, and then A, B, and then C. Right, you can start from anywhere. Right, you can start from point A. Just make sure you go in a anti-clockwise direction. So half times the absolute value of go right 16 B, and then A, and then D, and then C, back to B. Okay, remember, you have to go back to B. Okay, now I'm going to use brackets, right? So 1 times 2 plus 6 plus 28 plus 18. And I'm going to subtract the sum of the product of the other coordinates. So negative 6, 14 plus, minus 18, right? Because negative 6 times 3 is negative 18 plus 4. Okay? And then I'll just expand that. Okay, so since 60 is a positive number, right, the absolute value is still 60. If it's negative 60, you got to take the positive. Okay, remember it's the absolute value. So the area is 30 units square.